had some like introductory thing with our students here, so I can explain them for you, where you're coming from, and what is this all Web3 Academy about. So we gave them a little introduction about all the channels that we're going to be using, that we're going to add them to the Discord channels, etc. I'm going to forward all the emails after this lecture. But as I'm concerned, you can start your part, and we have a mic here, so if any students have questions, we're going to be turning in on and off as we go. So the floor is yours.
Amazing. Thank you so much. I appreciate that introduction. Thank you, everyone. I really appreciate everyone being here today. I'm very excited to teach you guys in this cohort, this special cohort for Pupin's Web3 Challenge. We're very excited to help you learn how to build on Web3 and on blockchain. Today is going to be the introductory session. So we are going to start out by kind of giving a little brief introduction of what the content's going to be like for the next 5 sessions that we'll be doing leading up to the hackathon. And then we'll also talk a little bit about today about how you build on Ethereum and what that actually means from a architectural standpoint, and teach you a little bit about what Ethereum is and what blockchain is. So yeah. Please go ahead and write down your questions, and then we'll try to leave like 10 minutes at the end, 5 or 10 minutes to answer those questions. But first, let me just go ahead and share my screen here. So hopefully you guys can see all this. I created a special Notion page. This Notion page is available. You can kind of scan this URL with your phone if you want to get it. Vladislav, I also sent this to you. We will also put this in the Discord server so that you guys can have it and you'll have access to it. But this is going to be kind of like your guide as you go through these sessions, right? There's a total of 5 sessions. We're gonna talk about those right now. But this is going to be that starting point. Going to go ahead and admit someone here. Okay, so again, thank you so much for joining. A little bit about me. So my name is Kevin Jones. I work in the blockchain space. I work for a protocol that maybe some of you have heard of called the Graph. But I also am a core member of the BuidlGuild, which is a group of developers that help the Ethereum ecosystem, and specifically for building on Ethereum, it's developing, right? Like creating applications. And so I do a lot of like education, teaching developers how to build on Ethereum. And that's, like I said, the goal of what we're going to be doing for all these sessions. In these sessions, you're going to learn the basics of Ethereum. You're going to learn the basics of what the EVM is, the Ethereum virtual machine. You're also going to understand a little bit of concepts of wallets and what we call accounts, externally owned accounts, and smart accounts, which are like smart contracts. We're also going to dive into Solidity and what Solidity is. It's a syntax language for deploying smart contracts, which smart contracts are just kind of like applications that are deployed on a blockchain. And then we're going to talk a lot about Scaffold ETH, which is a toolkit for building on Ethereum that comes with kind of everything you need to get started. And then on top of that, we're going to teach about some of the components and the hooks that are available in React for Scaffold ETH as well. So this helps you kind of build a front-end application for your decentralized application, your blockchain-based application, and much more. So we're going to learn a lot. This document also has a lot of interesting links that, I kind of created this notion where it's, you can go through it and explore and kind of dive deeper, right? So if you're not getting enough, or you want to kind of learn more about the concepts, we don't have time to cover everything about building on Ethereum, but there's going to be links for you on how to get in deeper and learn more. And so these are some like starting links that I would kind of recommend that you guys watch this week. These are things like how you can go to the Ethereum website and learn about the protocol. There's some docs there as well to learn about the docs. Scaffold ETH, learn about Scaffold ETH and what it is. And then there's a couple videos that you can watch as well, along with the slides for those videos that I would recommend that give you like a really like high level overview of what Ethereum is. Again, my name is Kevin. I work for the Graph. I'm also in the BuidlGuild. You can find all my contact info in this document as well. Please feel free to email me If you have questions, you can also reach out to me on Telegram, and I also am going to be in the Discord server. So please feel free to reach out. So there's this navigation tab here that you guys can use to go through all of the sessions. And this just kind of helps you go around and go through the document. So again, we're splitting this up into 5 sessions. This one today is going to be an introduction to building on Ethereum, along with some kind of take-home stuff that you can do, some homework. I wouldn't really call it homework because, we're not going to grade you on it, but it's stuff that I would recommend that you do to go through and learn more. Then the next day, next session, we're going to talk about EVM and more specifically Solidity, like how to write Solidity, what the syntax looks like. Then the next session, we're going to get more into like, what does a full-blown smart contract look like? Like, what should you build for a smart contract, and give you some examples of like a token, as you might know, like an ERC20 token. And then we go into like a little bit about the graph and what the graph is, and I teach you about data indexing in the Ethereum blockchain. And then the last step is we talk about the front end, like writing React hooks and components and all that stuff. So you're going to get this kind of like top to bottom, like basic overview of how to build. And by the end of this, you should be able to build your own application on Ethereum, which is really exciting. And there's a reference guide that gives you some examples. There's a frequently asked questions section. There's an additional resource with a lot of different links. And then again, after you're all done, there's a keep learning section where I'm going to put like, what do you do next? Like, how do you go further? Okay. Everything that we're going to do is pretty much on the command line. So depending on what operating system you're using, you need to install some things. So those are all here in the requirements. You need to have Node.js on your machine. Okay, Node.js is so that we can do some JavaScript-based stuff. We are going to be using React with Next.js, so it's primarily a JavaScript-based application. So you need Node.js 18 or above. You also need a tool called Yarn, which is like a package manager. And that gives you the instructions there to install that. And then your machine should be able to use Git, right? So you need to be able to check out Git repositories. Most machines come with that out of the box, so I don't think you'll need to install that, but just you'll be using Git. And then the last steps is you need an Ethereum wallet. So you need a way to talk to your applications on the blockchain. And so there's a couple choices for that. The most popular is MetaMask. So you can download the extension for your browser, which is Google Chrome. And I give you the instructions for that. Or you can, if you want to do it on your phone, there's also another app called Rainbow Wallet, which is really good. Either one works. MetaMask is probably the more popular and probably easier to set up, and you can just do it on your browser. And then the last thing is you might need Docker if you want to go through the graph stuff. The Docker stuff, you don't need to understand Docker, but we use it as like a virtualization layer for some of the implementations of the graph. So Docker is also going to need to be installed. So you can download Docker and install it on your machine. And this will allow you to kind of like do some container-based virtualization. And we'll talk about that more later on. That's not till like the 4th session. So. Okay, so the schedule again is these 5 sessions. It's available here. We're going to send out. I think we'll post this. You'll have this available, but I think we'll also maybe send out calendar invites so you guys can subscribe to those. Each one is about an hour long, and we'll kind of go from there. Okay, if you have problems, so I'll be on the Discord server, and then I'll also be available through email. You can also go join if for some reason you aren't getting a quick enough response from me, or you want to try to go to the general developer chat. There's a link here for the Scaffold ETH general developer chat, which is very useful. And that link's not working, but I will fix that. But there's a Telegram chat specifically for Scaffold ETH support, which you can totally ask questions in there. There's over 2,000 developers in that channel. So there's a good chance that someone will be listening and be able to help you if for some reason I'm traveling or something. Okay, so that's a very brief introduction of what we're going to do. So now I want to kind of dive in. So we have about 40 minutes for this session. but we want to leave some time for questions. So we have about 30 minutes, okay? So what I first want to talk about is what it means to build on Ethereum. So a lot of you guys have probably have some basic experience with like programming and writing some kind of basic programming language. Building on Ethereum is like building a normal application, but it's doing it in a what you might have heard the term Web3, like a decentralized way, a Web3 way. And so before we kind of dive into what Web3 is, it kind of makes sense to understand what Web2 is and what has changed between Web2 and Web3. So this diagram is actually just a really good overview of what that means. The traditional Web2 applications had a server, and those servers are primarily like centralized, right? Like Amazon servers, Google Cloud servers, servers that are in data centers that are controlled by individual companies. And then people are connecting to those servers directly, and the databases and the applications are all living on separate servers, but they're centralized. Really, the idea of Web3 is trying to dismantle that a little bit and decentralize that kind of layer. So instead of having one particular server, you have a blockchain-based system where all of the servers are connecting to each other and sharing their data. And by the use of cryptography, you can kind of create a chain of custody for the state or the database that's basically stored inside that blockchain. And you can kind of know that it's been untampered with and it's been verified. And so it's this concept of just taking this kind of centralization point of a single server and trying to decentralize it by the use of cryptography and by the use of blockchain, right? And there's a lot of, the blockchain space has a lot of different implementations, but for the most part, we're going to be focusing, or we're only going to be focusing on Ethereum, okay? Ethereum is its own blockchain. And what's unique about Ethereum versus something like Bitcoin, Bitcoin was originally created, it's not the first blockchain, but it's the first, I would say, mass adopted blockchain. And its primarily use case is for a store of value and for a cryptocurrency. Whereas something like Ethereum has added utility. It is a cryptocurrency and it does have the ability to store value, but it has the ability to execute inside of its environment, what's called the Ethereum virtual machine, programs, applications. So it actually allows you to take business logic that you would normally only be able to deploy on like a server, like a Node.js server or a Go server or some other programming language. And it allows you to write simple, smart contracts that can be deployed on that blockchain as what we call programmable money. And so that's kind of the most powerful thing about blockchains now is the ability to take this concept of cryptocurrency and money and mix that with business logic, right? And that's the power of Ethereum, is it's the most popular platform for building those smart contract-based applications, okay? So hopefully that was a good, like, very high-level primer of what Ethereum is. We're going to dive much deeper into like what it means to run an Ethereum node and how the smart contract data is executed. But for the most part, you can think of it as just APIs or applications that are deployed on the blockchain and made accessible in a way that is censorship resistant and distributed and decentralized. Okay. So there's a lot of reasons why this is powerful. Again, I think the most important thing is that the concept of smart contracts. So again, you can think of smart contracts as programs that have been deployed on a blockchain that don't require any third-party intermediary. So in other words, like if I want to buy a car today, I could go to a car dealership and I could buy a car directly from the dealership, right? I could also buy a car directly from someone. Most of the time, if you're going through a dealership, you buy the car and the car has been kind of like brokered from someone else. Someone bought that car. And so there's this kind of like middleman. The concept of a smart contract allows you to execute a transfer of value between two people by the use of the smart contracts logic. So it's like this user wants to connect and this user wants to connect to the smart contract and do a transaction, and it eliminates the need for an intermediary. So it's kind of like taking the logic of what a credit card or a bank has already built in and just removing the need for anyone to run that. It's all automated, so automated contracts. And so what this does is it really gives you this ability to, like I said, transact in a way that is, no need for third-party trust, and really allows you to, build some really interesting things that can be kind of just decentralized and sent out there. There's a lot of there's these little sections where I put videos in here, so you'll see a little TV, and you can expand that. And this will teach you a little bit about asymmetric encryption. If you don't understand what that is, it's kind of the most important thing for blockchains is how the chain of custody is created by using encryption. And so it's good to understand that. I would recommend watching anytime you see a video, please watch those videos on your own time. We're not going to watch the video together right now. We're going to try to focus on the next steps. And so again, building an application on Ethereum allows you to have, well, first of all, zero downtime, because there's so many instances of your application deployed. You don't have to worry about one single server going down because it's distributed. You also have this concept of privacy. You don't have any one particular intermediary that is responsible for authenticating you. You're using a private key that you sign your transactions with that is completely private. So that's really great because it's not tied to any like KYC. You can just interact with the blockchain. It's permissionless, right? It's also resistant to censorship. It also has the ability to have data integrity built in because it uses a blockchain-based system. You can build applications that are really cool. And then it's trustless and verifiable, right? Everything on a blockchain is very expected, and you can kind of understand that if this transaction went through and it's verified, it's intact and verifiable. So there's a lot of reasons. There's also a good amount of examples of what you can build and what people build. You might have heard of like a centralized exchange. A lot of people are building decentralized exchanges. So I have a bunch of examples in here of reasons why blockchain could kind of disrupt different use cases. And so I would recommend reading through those. We're not going to go into those too much. And then there's another video that talks very basically about how a blockchain works. We're not going to get too much into how a blockchain works because we're going to focus more on the building aspect of it. And a lot of that stuff is kind of abstracted away for you. But if you want to learn more about how a blockchain works, this is a very good visual demo that talks about hashes and how the chain is created by using a blockchain, right? That's what a blockchain is. Again, so please watch those videos in your own time if you have some time, and we'll go from there. So again, we're talking about Ethereum. I'm going to go through this a little bit, but basically Ethereum is the most popular way to deploy smart contracts. And it allows you to use cryptocurrency to pay some value into a transaction. So you can basically submit a kind of like if you were to submit a request to a server to like log in and change something, it's the same thing. You submit what we call a transaction. It's a transaction-based system. And it allows you to, again, have programmable money. So you can make that transaction have functions just like a normal application. It can have variables. It can do mathematical operations. So it is a programming language. And everything is executed inside of this Ethereum virtual machine. Okay, so I talk a little bit about how you communicate with a blockchain. I want to kind of talk about that briefly. But for the most part, as a user connects to an application just like they normally do. They go to the website, they type in the website. But instead of signing in with a normal like login like Google, or using like a username and password, you sign in with a wallet, right? A wallet is kind of like a cryptographic key that is stored inside of your browser in a secure way, so it can't be accessed by another site. But it allows you to use your private key to sign a transaction and to interact with the blockchain, okay? And so there's a lot of different ways that that's done. but for the most part, it's usually done through a front end, right? So through your front end application, and you use some kind of framework to do that. So an example would be Web3 JS, which is like a JavaScript framework, or Ethers.js, or there's another one called VM. And so there's a lot of different ways you can interact with the blockchain, but for the most part, that's how it works, is there's a SDK or some kind of front-end code that is written. And then you communicate with the blockchain over what's called an RPC. So it's basically an API that is distributed. An example would be Infura. There's a company called Infura that does a decentralized RPC. So it's kind of like a decentralized API for the blockchain. Or you could run your own copy of the blockchain. So you could run what's called Geth, which is a blockchain node, and you could communicate it. Pretty much everything we're going to use is going to be Alchemy, which is another one, Infura, Alchemy, or you can run your own node. So there's different ways. And then from there, you can make connections to the blockchain and do transactions, okay? So this is kind of like the flow of how a transaction works. And again, I'm just trying to give you guys a high-level overview. We'll dive into this a lot more deeper in the coming sessions. And so eventually you hit a smart contract, and you hit the Ethereum blockchain. So the Ethereum blockchain it's just a database, right? A decentralized database, really. And it has a storage for different things. So it has a smart contract storage system. It has an account storage system, so you can create accounts. And it also has the ability to, let me add these people to the waiting room as well real quick, sorry. Okay. Okay. Okay, so yeah, so basically we're going to use this kind of like method for our application that we're going to build to connect to the blockchain. And then again, so I've been talking a lot about transactions. What is a transaction? It's really the way that you communicate. Is you can basically take you can sign a message and ask to change a state. So you can think of like state as like values inside the database. All applications have state. You have variables that get updated as you make changes to your application. It's the same thing on the Ethereum blockchain, is you propose transactions to change those states. So in other words, let's say I want to send 1 ETH to my buddy and I send a transaction with that value transfer, that is updating the state. So I pay some value and then that value gets transferred. So it's this concept of moving state from one state to another state by the means of a transaction. And so the way that's done is primarily through what's called gas. I'm not going to get too much into it right now, but for the most part, you can think of it like you need gas for your car, right? You need to be able to get in your car and drive to work, right? And then you need to have gas in your car to drive home, right? So it's the same thing with Ethereum. Every time you propose and submit a transaction to update state, you need to pay this gas. And it's kind of like the incentive layer for securing the blockchain. So you can think of it as this. There's hundreds or thousands of nodes running for the blockchain, and all of them need to compute all of the changes because they're all working in a decentralized way. However, they need some incentive to do that. And so in order to have people run nodes, they need to earn some value. So they need to earn some ETH or some Ether. And so this is done by a concept of gas. So depending on what you want to update, we have to update that across all of the entire blockchain. You need to pay a certain amount of gas. So this is kind of this idea of like proposing transaction. Instead of you paying, your bank to do a transaction, you're paying the blockchain and you're distributing that value into the blockchain. And then that code is executed. There's lots more that goes into gas, but for the most part, you can just think of it as that. It's the power. It's basically what powers the Ethereum blockchain. Again, you might have this concept of a state change, right? And these are handled in blocks. So we talk about blockchain, that's the word, right? Blockchain. So a block just has a bunch of transactions in it, and then the state is transferred in that block. So if we look at the Genesis block, which is the very, 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 very first block of Ethereum, it's going to be completely different than today's block, right? Because there's been so many state changes over the years. And again, that video that I recommend you watch talks about how that works, but it uses hashing to kind of secure that kind of entire chain. And so, yeah, there's been basically millions of blocks that have been formed on Ethereum. And so they're all kind of verifiable using cryptographic hashes. But that's a high level overview. So you can think of a block as a bunch of transactions in that particular block that update the state of the blockchain, right? And so this world state is kind of like shared amongst all of the nodes. There's actually a really good video here as well that talks about eth.build, which is and how transactions work by Austin. Austin is the creator of Scaffold ETH, and he's the creator of the BuidlGuild, and he's a mastermind. He's amazing. So I really highly recommend you watch those videos. This one is a good primer to understand how transactions work. And you guys should take some time to read that. Okay. So now we're going to get into, we kind of gave you a very high level overview. I want to show off Scaffold ETH for you guys. And this is just because it's going to be the main thing you guys are going to be using for all of your lessons and all of your homework that you're going to have to do. And we're going to talk about it now. Scaffold ETH, again, it's this complete kit that comes with everything you need, right, to build on Ethereum. It comes with a front end, so it comes with React with Next.js. It comes with a back end, which is a virtualized blockchain. So Ethereum blockchain is out there in the world, right? Everyone's running an instance of it. But if you want to test and build your applications locally, then you need to use some kind of virtualized blockchain. And so there's a couple popular ones. Hardhat and Foundry are the most popular, and this comes with either one. So you can use Hardhat or Foundry. We'll go more into that, but it's a blockchain that runs on your laptop so that you don't have to connect and pay real money. You can use fake money to do your building. And then it has a bunch of other stuff plugged in to make it easy to communicate with the blockchain as well. So it comes with WAGMI, it comes with VM, which these are just like packages, like SDKs that allow you to communicate with your smart contract. And it's fully written in TypeScript, okay? So TypeScript is a superset of JavaScript. What that means is it's basically JavaScript, but it has like a lot of cool features that allow you to do what's called type safety. Some of you might know what TypeScript is, some of you might not, that's okay. But it looks a lot like JavaScript, but it's a little easier to navigate and learn on. So it's actually good. And I highly recommend anyone who wants to learn TypeScript do that. And it's got a lot of other features, but we're going to set it up right now. So we're just going to go ahead and I'm going to show it off a little bit. And then you guys are going to be able to do this at home, hopefully. And if you have problems, we'll try to help you out remotely. Okay, so the way Scaffold ETH works is I'm going to use my terminal here. And the way Scaffold ETH works, it is a command line tool. So, you need to have a terminal. If you're running Windows, you should probably have Linux for Windows installed and set up. I would recommend that. Mac, you should have no issues. It's very easy, but if you're running Windows, make sure you have Linux WSL installed so that you can use the Linux shell. And we're going to set it up. So the way you set up Scaffold ETH, if you go to scaffoldeth.io right here, scaffoldeth.io, it tells you two ways you can do it. We're just going to use this NPX method, which is the most popular method, I would say. Now, it says beta, but it's not beta anymore. It's valid. So it's going to tell us how to do that. So we can copy this to our command, and we can just paste it in here, okay? So what this is going to do is it's going to ask you if you want to install the most recent package of create-eth. So create.eth is like a installation script for Scaffold ETH. So I'm going to say yes and hit enter. So this is going to set up a project for us, and it asks us what we want to call it. So we'll call this Pupin, like that. And then it's going to ask us what framework we want to use. So again, Scaffold ETH supports both Hardhat and Foundry. I would recommend that everyone just uses Hardhat for now. If you, for some reason, already know about how to build on Ethereum and you don't want to use Foundry, that's okay. but I would recommend anyone new just to use Hardhat, okay? And that's because Hardhat has been around a little longer. There's more documentation for it. It's a little more predictable. Foundry is a little faster and a little newer, but there's some caveats with it. So I would really recommend Hardhat. It's just easier. So when we do that, it's going to set up a package for us. It's going to basically like install all the dependencies using what's called Yarn. Yarn is a package manager. And what this is going to do is it's going to set up this kind of bare bones environment for you that's kind of ready to go, right? And it's going to give you this output and say, congratulations, your project has been scaffolded. What do you want to do now? And it tells you how to start up your blockchain, and it tells you how to start up your front end, and it tells you how to deploy your contract, okay? So it says, go into the Pupin directory. So we'll go into that. So we go in there, and then it's going to ask us to install the chain. Or set up the chain. So we can just type yarn chain. So yarn chain will spin up a blockchain, basically. It's kind of crazy, but it's just this blockchain running on your machine that is just like Ethereum. It allows you to has the same syntax. It allows you to write smart contracts, and you can see it comes with ETH for you to test with. All of these private keys and public keys are available for you to test with. And so this is really useful for like prototyping and developing on a local machine. So it's going to get you set up. Now, the next thing is you need to open a new window, because this one, you're always going to keep the blockchain running, okay? So I use a tool called Tmux, which allows me to split my screen. You don't need to do that. You can just open a new terminal. So you can go File, New Terminal, and open a new one and just keep the other one in the side. But I use this. And then we're going to go into the same directory, and we're going to do the deploy. So again, Scaffold ETH comes with a smart contract that we can deploy, and we'll take a look at it in a second, but you'll be able to see it, and you can see we get some output, and you can see that it was successful. It says you compiled your contract and you deployed it. Here was the transaction, and here's the contract address, and it gave us some output, and it updated the definition. So you know it's successful when it says this. Congratulations, you deployed it. That worked. So what we need to do next is we need to have a third window. Now, the first window is our blockchain. The second window is where we're doing our deployments and just typing yarn deploy. But in the third window, we're going to run our front end. So we need a back end to deploy our contract to, and then we need a front end to interact with it. So let's go into the same directory. And this one, we do yarn start. And this is all in the Notion. So you guys should be able to do this on your own. Okay, so there we go. So it's starting and it's available. So now we have our blockchain up, and we have our front end up, and we have the script deployed, and it tells us what port that our application is on. So it's on port 3000 on localhost. So let's go there. Let's check it out. So we're going to go here, and this is Scaffold ETH. So it takes a second because it has to compile all the front end code, but just take 1 second, and we'll get that loaded up. Here we go. Okay, so when you first get connected, this is what you'll see. You'll basically see that we have a front end. This is all JavaScript it's React with Next.js. We have this kind of like wallet automatically connected. So what's cool is about Scaffold ETH is it comes with a wallet that is already built in to your smart contract or to your front end. So you don't need to have MetaMask right away, but eventually you're going to need it. So install MetaMask, but it comes with this wallet that's in there. And then what you'll notice is there's this debug contracts tab. So if I click that, this is where the real cool part of Scaffold ETH is it builds out a front end for your application based on your smart contract that comes with Scaffold ETH, or as you write and make changes, you can deploy it and see those changes immediately, which is really powerful. You'll kind of understand that later, because normally you have to build your own UI to test something. And so that can get very hard to do quickly. And so this is nice because it builds this for us no matter what we do. So we can kind of know that this is a very basic smart contract that has some functions. It has a read function, a write function, a couple write functions, and it's got some variables here. So these are all the variables defined. And we can, the ability, you'll see there's a variable called greeting. So you can think of this like as a greeting. It says building unstoppable apps. And it has an owner address, which is, this is an Ethereum address. It has a Boolean and it has a counter. And you'll see that there's a write function that allows you to set this greeting. So there's a greeting here and we can set it. So we can type a new greeting here. So let's do that. We'll call it hello Belgrade, like this. And I can hit send. It's going to tell me I don't have enough funds to pay for gas. So we talked about gas earlier. You need to pay some gas to update state. So we're trying to change this greeting from building unstoppable apps to hello Belgrade. I need to get some gas. So there's a button for that. We can grab some funds from the faucet here. And now we'll have 1 ETH in our wallet, our local wallet. And now we can hit send and upgrade the state. And you'll notice that it gets upgraded. And we notice we have a counter that increased. And yeah, we can also check the user counter. I could come over here, copy my address and read from the contract, and I get a value of 1. So anytime you want to write to the contract, you need to pay gas. Anytime you want to read, you do not. And then all the variables are here. So let me just show real quick what the smart contract looks like. We're getting close to our time of what I wanted to stop at so we can answer questions. But if we load up, so I use VS Code. So I just type code dot, but you can open up VS Code. It's your text editor. You need some kind of text editor to edit the smart contract. So install VS Code or some other similar one. Cursor is also good. And go here to packages and go to hard hat. So you'll notice there's 2 packages. So Scaffold ETH is a mono repo. It comes with a back end and a front end. So a hard hat, which is our chain, Next.js, which is our front end. So if we go to hard hat and we go to contracts and we go to your contract.sol, so all Solidity files are .sol, and we have this contract. So it's exactly what we saw when we navigate to Scaffold ETH's debug contracts tab is all here, but it's the code. So if I come in here and make a new variable and I say string public hello, and I make it say hello world and save that, and then come over here and deploy again, deploy, it'll be successful. And then I can come over to Scaffold ETH and we can see it reloads. And now we have the new string. I could also add like an integer. Let me do that. Let me say unsigned integer and public and call it counter equal 0, save, and then deploy. So you get in this thing where you try to make some changes to your smart contract. You try to deploy those changes, and then you test them and see if they show up. So now we have a counter, right? And so maybe I want to create a function to increase the counter. Let me do that. Function increment. And I'm just kind of showing you off what we could do here, but public counter +1. Now I want to make one that maybe decreases the counter, right? There we go, counter -1. So this will add to the counter. This will remove from the counter. So now I could save that and then deploy. So you get in this habit where you start writing Solidity, come over here, deploy, go to your front end, and then you can see now we have these new functions to increment and decrement. So I have the counter to 0. I should be able to say increment, 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 and increase it as I want. And backwards, same thing, decrement, 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 right? So that's the kind of the pattern for building on Ethereum is you spin up hard hat, spin up Next.js, you deploy your contract, you start learning how Solidity works. And so there's a lot that we're going to go into on the next session, but we're going to use what's called Solidity by example, which is a really cool tool for like learning how Solidity works. Majority of what we're going to be doing is all Solidity pretty much, and understanding how you write smart contracts. and we're going to try to deploy smart contracts and work together to go and learn about this stuff. Next time we meet, we'll go into more detail about what EVM, how it works. We'll talk more about Solidity syntax. And then we'll also, if we come down here, all these steps that I went through are all here. So you should go through and do that yourself, okay? But there's this section for homework. So it's not like real homework, but I would recommend you guys do it. This is, first of all, make sure you install all of the dependencies that are in the requirements area. Set up an Ethereum wallet. And then go through everything I just did on your own time, reading it and watching the videos if you can. And lastly, I want you guys to go to Speedrun Ethereum, okay? Now, I didn't talk much about Speedrun Ethereum, but Speedrun Ethereum is this kind of like challenge platform, all based on Scaffold ETH. So everything that you're going to be learning along the next, few weeks, month, is all going to be based on you being able to complete these challenges. So all these challenges are kind of like checkpoints to see how well you're learning along the way. The very, very first one, this simple NFT challenge, I want you guys to try to do it on your own, okay? It's very easy. You just come over here. You'll connect your wallet. So the first time you come here, you'll come here and say connect wallet, and you'll go to MetaMask, and it will sign you in, and it will create a profile for you. Then you can just click on Quest, and you can go through and do all of these challenges, right? So it's going to be a total of 3 challenges that you'll do. This very, very simple, very first one is really, really easy. And then you can click Submit Challenge, and you can put the deployed URL there and the Etherscan URL. So this takes, like I said, you could probably do this challenge if you're really good in like 30 minutes. But otherwise, it might take you maybe a couple hours if you go very slow. If you get stuck, please let me know. I'll be in the Discord. There's a time difference. I'm in California in the United States, but please ask any questions. And again, if you can't reach me, you can also join the Scaffold ETH chat for help. And I think there's actually a link to that in here. I think if you get lost, there's the ability to go that. I don't know exactly where it is, but maybe it's on the bottom. Actually, if you go to the README that I created this here, I would just join it. I'll add the link in here at the top just so that you can ask questions. I'll put it right here if for some reason you can't get a hold of me. But okay, so I think that was a pretty good introduction. So I think right now what I'd like to do is stop and use this last 7 minutes to answer questions for you guys and see how you're feeling about all this stuff, okay?
Thank you, Kevin, for this very short but really interesting for me lecture. I listened to a lot of similar stuff, but I think you explained it for me in a really understandable manner. So round of applause for you and for this first lecture.
Thank you so much. Thank you. I'm happy to help.
Any of the students have any questions? Do you have, guys, any questions? I guess you have a lot, but maybe you're shy. Yeah.
Can this be done in a Windows terminal?
Can this be done in a Windows terminal? But I don't think.
Yeah, it can be done in Windows. It's just you need to have WSL, like Linux, installed on Windows. So like Ubuntu, I think, comes with Windows now. So it's like a shell within Windows. So you're kind of like using Linux to do everything. But it can be done. I don't know about using like PowerShell or like terminal. That might be kind of hard and you might have some issues. It might work, but for the most part, you should use WSL if you can, Ubuntu WSL.
I am using WSL as well. It's really easy to set up. You need like 2 minutes to set it up, and you just use it on your Windows machine without actually booting up Linux. So it's not going to be too hard for you guys. Any other questions? Nemoj. I have a question. Can you maybe tell us more about what type of apps are we going to be building next 5 weeks?
Yeah, that's a great question. So I think for like applications, so The next time we meet, we're going to go over the basics of just what Solidity is. We're going to talk about like what a function is, how you declare it, stuff like so. Really the basics, and like we're going to kind of open it up. Like, hey, maybe you build something just on your own, what you think's cool. But the third session, we're actually going to deploy a token, so an ERC20 token, and then. The third session is the fourth session is we're going to build like kind of like a messaging tool that you can send messages between two people on the blockchain, which is very, it's not the perfect implementation, but it's a cool show off of how events work and stuff like that. And then the very last section, I think we'll do an extension of that and maybe build out the UI. But it'll all be like token-based stuff. And then inside of sorry, I should probably share my screen again. The very, very last, the other two sections that you're going to do. So the simple NFT teaches you how to build an NFT. That's the one that you guys should be doing before we next meet. And that one is like a very basic kind of like NFT. The next one is a staking app. And this one gets a little more difficult, but you learn the concept of like staking tokens and getting back an alternate token as your stake. You learn a little bit about how that works in a blockchain. And then the very last is a token vendor. So it's where you can like deposit some ETH and get back some other tokens and kind of like create like somewhat of an exchange, but a way to purchase tokens using a smart contract. So yeah, that's kind of the majority of what you learn.
Thank you for that. Do you guys have any more questions? I think we're done for tonight for the questions, but I will send them the links for the Notion and everything so they can join Discord. And if they have anything in between, they can message you or any of us. So thank you, Kevin, once again, and we'll meet you next Tuesday as well.
Amazing. Thank you guys and good luck. And yeah, just keep building and let me know if you have any issues.
And I just wanted to ask you if you can forward us the link of the video when we finish a recording of the session.
Yep.
When we're
yeah, I'll send it over later today.
Thank you very much. Bye.
Bye guys, see you next time.